this lesson, we will be solving linear inequalities. First, we need to discuss the interval notation way of representing the solution set to an inequality. The far left number will be the smallest number of your solution set. If it is to be included, you use a bracket to the left of it. If it isn't to be included, you will use a parenthesis. There's a comma between the lower and the upper bound to say all real numbers between these two numbers. The upper bound will also have a bracket or parenthesis to the right of it, dependent on whether that number is to be included or not. So let's say our solution set is any number, any real number greater than 3. To help with our interval notation, let's graph this on a number line. On the real number line, you will see the 3 is the lower bound, and it is not to be included. While we're going every number to the right of 3. The set goes on forever, so we will use infinity. Always close infinity with parentheses. Here our solution set is all real numbers less than or equal to -1. The upper bound is -1, and it's to be included, while then all numbers to the left of -1, so we're going on forever in the negative direction. If our solution set is all real numbers, then you're going off indefinitely in the negative and the positive direction. This inequality is referred to as a double inequality for obvious reasons. With the inequalities as less thans and the x in the middle, we will read this as all real numbers between 3 and 5, including 5. The lower bound is 3, don't include, so use parentheses. The upper bound is 5, we do include, so use a bracket. This slide restates the steps to solving linear equations. We will approach inequalities with the same process, except step 5 might be different. When you multiply or divide by a negative number, you must flip the inequality. If you fail to, you are stating all of the numbers that actually don't work. Again, treat this like an equation, so get rid of parentheses by distributing as your first step. Collect like terms on the left, and then go on and do the same on the right-hand side. Now we're ready to start moving across the inequality. With inequalities, I always move the variable to the left, and then the constant to the right. You don't absolutely have to do things this way, but it seems to make it easier for students when solving inequalities. Now look at the second to the last step. We have -2x less than -12. It is at this point that you divide, and since we are dividing by a negative, we must remember to flip the inequality. There is nothing that will remind you to flip. You just need to remember to do so. Again, and you do so when you multiply or divide by a negative number. And in the end, state the solution set with interval notation. Until you are thoroughly comfortable with interval notation, draw a number line to assist you. The number line seems to help many students until they're comfortable. We move on to double inequalities. We are done when x is alone in the middle. This time, what you do to the middle, you must do to the other two parts. We'll start by distributing. In isolating x, we typically move the constant first, and then we'll divide by the coefficient, divide by 2. So adding 6 to all three parts, and then next dividing by 2. Since this coefficient of 2 is positive, we will not be flipping the inequality. We read our solution set as all real numbers between 1 and 5, including 5. Again, represent this with interval notation. Use the number line if necessary to assist you. Because the author has phrased this question, find the minimum sales that allows Alex to earn at least $3,000 per month. This needs to be set up as an inequality. At least means that much or more. This translates to a greater than or equal to. Our unknown is sales. We define this, and then we write an expression that represents Alex's earnings. Alex earns $600 plus 4% of his sales. He wants this to be at least greater than or equal to $3,000. You are left now to solve, and what we find is that the sales needs to be $60,000 or more per month in order for him to earn $3,000 or more per month. Hopefully, this has been helpful. Thank you.